Dear participants, on behalf of SNS College of Engineering, Coimbatore, I'm happy to welcome you all for day 4 of the 6 days online ATAL FDP on Revolutionizing Energy, the Role of Disruptive Technologies in Electrical Systems. Today, we have Dr. S. Charles Raja, Associate Professor of Tyagaraja College of Engineering, Madurai, with us. Dr. S. Charles Raja is a prominent academic and researcher in electrical and electronics engineering. He has completed his BE in electrical and electronics engineering at MEPCO Shillong Engineering College, Shivagasi, in the year 2005. He pursued his ME in Power Systems at Tyagaraja College of Engineering, Madurai, in 2007, and obtained his PhD in electrical engineering with a specialization in restructured power systems from Anna University in 2013. He has accumulated over 16 years of teaching and research experience at Tyagaraja College of Engineering. He started as a lecturer, served as an assistant professor for 11 years, and currently working as an associate professor with nearly 3 years of experience in this role. He has guided 12 research scholars and contributed to the academic community with 114 publications in international journals. His research efforts have earned him an H-index of 8 in Scopus and 10 in Google Scholar. He has received 2 major project grants totaling 40 lakhs. His award includes Early Career Research Award from Science and Engineering Research Board, Career Award for Young Teachers by AICT in the year 2014-15, Young Scientist Fellowship Award from the Tamil Nadu State's Council for Science and Technology in the year 2010. He is a recognized supervisor under Anna University's Faculty of Electrical Engineering. He has organized 2 TQIP-funded workshops, 1 national conference, 1 IEEE-sponsored international conference, and an AECT-sponsored STTP. He has delivered 11 guest lectures and actively participated in various academic forums. He has received multiple Best Paper Awards, including Energy Management of Hybrid Energy Storage Systems in Plug-in Hybrid Electric Vehicle in the year 2019, Smart Grid Initiative in Institutions in the year 2019 again, Application of TCSE to Congestion Management Problems in Deregulated Power Systems again in 2019. His dedication to teaching, research, and innovation continues to inspire his students and peers. His expertise in smart grids, power systems optimization, and renewable energy integration positions him as a leader in this field. So we are very happy to welcome you. Over to you, sir.
Thank you, ma'am. Ma'am, whether my screen is visible?
Yes, sir.
Good evening, all. First of all, I thank Jabrani ma'am for giving this opportunity to deliver the guest lecture on this ATAL FDP. So the topic of today's lecture is IoT-based smart demand-side management system, technical overview and deployment at an educational institution. Last 10 years, I am working on this IoT-based smart demand-side management system. So based on my expertise, I am going to cover the following details in my presentation. It starts from recent trends in smart grid technologies, history of smart meters, evolution of normal meters to smart meters, then difference between conventional meters and smart meters, then technologies related to conventional and smart metering, then various of smart meters normally available in the markets. So we will discuss one by one. Evaluation and deployment of smart meter technology. Then there are 2 eras in the smart grids. One is automated meter reading, that is the first era. Second one is advanced metering infrastructures. So these 2 we are going to cover. Communication infrastructure and protocols. Then So up to this, we are going to cover the theoretical part of my presentation. Next part is my research oriented thing, state of art of TCE campus, that is our college campus, where we were installed many meters, smart meters, and we convert our normal infrastructure into advanced metering infrastructures. So pilot study with these data will be discussed in this lecture. Then how we can integrate the small demand side management in our real time, that also I am going to cover. So these are my overview of today's presentations. Now I start my presentation with recent technologies tools available in smart grids. So one of the key area in power system or electrical domain is smart grid. So this is the key word normally people used for doing their research, writing.
Sorry to interrupt, sir. Sorry to
Yes.
interrupt, sir. Screen is not visible, sir. You are not sharing the screen correctly. Yeah, now it's visible, sir.
Yes. Now?
Yeah, now it's working, sir.
Okay.
Right. Okay.
If there is any interruption, please tell me so that we can have a good.
Yeah, sure, sir.
Okay. So it starts from advanced metering infrastructures, SCADA systems, phasor measurement units. So these things normally used in transmission system and distribution system. So when we use phasor measurement units in transmission system, so that is called a wide area measurement system, WAM systems. Nowadays, in power system or power grid, a lot of renewable based energy sources involved. So that is distributed energy resource management system, energy management system. Then microgrid technology. So in remote area or interior area, if there is no power grid, power source, some microgrid based technology can be used to give power to that interior area. Then demand response technology. So in this lecture, we are more focused on this demand response technology, renewable energy integration technology, energy storage technology. So in that distribution side, so main focus on nowadays is electric vehicle integration, communication technologies. Then the many tools normally used in this smart grid applications, such as artificial intelligence and machine learning, big data analytics, blockchain technology, cyber security technology, then advanced sensor technologies. So these various technologies normally used in this smart grid. Now we starts from history of smart meters. So in 1872, the first electric meter invented to measure the voltage and current. So in 1889, the first energy meter using spinning disk energy meter is was invented. So after that, 1980, solid state digital meters. So there is no moving parts inside the meters. So that type of meters were invented in 1980. Then in 1990, the revolution has been implemented in the meters, that is first automated meter reader. So the reading can be automatically fetched. That facility was introduced in 1990. 2009 onwards, in foreign countries, people were used to smart meters with two-way communications. So either a utility or a consumer can communicate through the smart meters in order to facilitate demand side management. So this is the evolution of electricity metering. It starts from 1972 nowadays. So that is mainly this diagram focused on the communication based thing. So in 1970, the low-level communications normally used in the metering technology. Nowadays, we are using a high-level communication technology. We are using. So based on the communication technology, so has been classified into two major era. One is automatic meter reading. So that is called AMR. In that type, one-way communication is normally used. All data can be fetched from the meter to a utility server. So that can be possible in the automatic meter reading type technology. Whereas in the smart metering technology, two-way communication is possible. So utility can also communicate to consumer, as well as consumer can also communicate with utility. So through smart metering. So major applications related to this advanced metering infrastructure is AMR, demand response, remote connect, disconnect, other smart metering applications. So in addition to that, nowadays we are having a cyber security based advanced smart metering technology. This is the basic difference between conventional dump meter to smart meter. So usually dump meter, it's a isolated meter, or in a meter which is not connected with any other server or some concentrators. So this meter will be used for getting the reading or measuring the reading for a particular appliances or particular household. So all data is normally available in that meter. So we can have a manual for getting the data in the dump meter. Then based on the and the data read by the manual can be stored in the database. So this is the normal procedure nowadays we are using in our TNEB. Whereas in the smart meter, all meters are connected through a communication protocols, or communication, wired communication or wireless communication. So a lot of protocols normally used for this. So this smart meters normally connected through gateway and interface protocol to database management systems. So every single second or minute data can be stored from the meter to the database management system. This is the main advantage of smart meters technology. So this is the process flow in the metering technology. So it starts from conventional metering to smart metering technology. So I focus on the smart metering technology. Here usually we have three different level of area network. So neighborhood area network, local area network, wide area network. So based on the connection of each smart meters, this will be normally classified as either home area, neighborhood area, or wide area network. So multiple homes are having multiple smart meters. They are connected, interconnectedly connected. Then that is called home network. So all home area network normally connected through a neighborhood area network or wide area network, that we will discuss later in detail. Then various types of smart meters available. So usual type, first one is local automated meter reading. So here usually meters are connected locally. For example, if we are having placed meters in apartments, so in an apartment we have more than 20 houses. So each house is having its own meters. They are connected locally. So all meter reading can be fetched in a single server. So this is called a local automated meter reading. Then we have another type is called a network metering technology. So here a meter can be connected through a wireless or wired network with a long distance or short distance. So some geographical area, smart meters area meters are connected together through the network, that is called a network meter. The third type of smart meter is net meter. So net meter is nothing but this meter is capable of measuring both export as well as import energy. That means, suppose in our house we have a solar panel, uh, we have to install a net meter, a special meter, dedicated meter to measure our net consumption. So TNEB has given the provision to install that net metering. So in this meter can be are able to normally able to measure the uh, generation of solar panel output as well as our consumption. So based on the generation as well as our consumption, this will give the net meter reading. So this is called net metering. The last type is a remote automated meter reading. So this is the latest technology normally used in the foreign country, where all meters are connected through a communication protocol like a GSM, GPRS, or a wired LAN network. So the meter placed far away from the server or far away from the another meter easily connected through this communication protocol. Now, all meter reading can be easily fetched. So these are the various types of smart meters. Now the smart meter technology evaluation so starts from first generation to third generation. So analog meters normally were used in the year 1872 to 2005. After that, first generation meter, normally it is called automated meter reading technology. That is one-way communication is normally used. The functionality of one-way communication, that is AMR, is automated monthly reads, one-way outage deduction, tamper detection, load profiling. So these functionalities can be possible in this AMR, that is first generation smart meters. The range of usage here is, this is 1990 to 2005, the year 1990 to 2005. The second generation smart meter is nothing but AMR plus. So, in addition to the functionality of AMR, it has additionally daily or on-demand reads, hourly interval data, outage notification, other commodity reads. So nowadays we are having SMS alert from TNEB. So we can say it, we are under AMR plus. So this range is around 2006 to 2008. In foreign countries, normally people are using the AMI facilities, that is full two-way communication protocols normally used. So this is under third generation smart meter technology. So the functionality of this third generation technology is it integrates a service switch, time-based rates, that is time of use based tariff can be used in this AMI technology. Remote meter programming, so utility can do the metering, some program, for example power factor corrections or power factor low or high power factor. Based on the power factor thing, they can switch off our appliances. Then power quality based things, HAN interface. So these facilities are normally used in the AMI, that is third generation smart meter technology. So nowadays foreign countries used it, starts from 2009. So now we move on to first AMR technology, that is the first generation of smart meter technology. So it is a remote reading system that permits utilities to read electronic meters over long distance. So this type of meters usually having a single way or one way communications. So utility can communicate with this meter. Can permits utilities to read electronic meters, that is reading of electronic meter over long distances. Through AMR, the energy consumption can be read annually, monthly, weekly, daily, or hourly. The automatic data collection enables billing based on real-time consumption as opposed to estimated consumption. So there is no estimation process available in this AMR technology. It gives only actual reading, that is real-time consumption based reading. So utility can get the real-time data from the AMR metering, then they can, it can be utilized for further process, for billing process or some other process. So the primary purpose of AMR technology normally used for customer billing, improve metering accuracy, reduced cost of meter reading. So AMR technology comprises static meters fitted with communication devices. So what are the communication normally used in this AMR technology is wired or wireless telephonic communication, radio frequency or power line transmission based communication. The final one, touch technology, a person can come over the meter and a meter reader carries a handheld computer device with a probe. So using this meter, he can collect all the data available in the particular meter. The device collects the reading from a meter by touching the meter with a probe. Close proximity to a reading a coil enclosed in the touchpad. So based on this concept, this touch technology normally used in the AMR technology for collecting data. Now we move on the advanced metering infrastructure. So usually this is the latest technology used in the smart meters. So it refers to systems that measure, read and analyze energy consumption. So not only measure or read the energy consumption, these type of meters are able to analyze the energy consumption. So which type of pattern normally use a particular house, so what is the peak hours of the particular house. So these things can be easily available in the AMI based technology. So AMI system can be defined as the extension of simpler AMR system. It always communicates two-way and comprises the whole range of metering devices, software, communication media, and data management system. So all major parts are covered in the AMI technology. So this is the architecture of AMI technology. It has basically 3 levels. It starts from basic to advanced. A particular meter, smart meter, maybe in the AMI technology with any one level. So it may be a basic level or medium level or advanced level. So based on the cost, it will be go up to advanced level. In the advanced level, we can have all communication related things in the particular meter. So now we starts from basic level. In the basic level, all basic things, current, voltage, sensing elements, then energy metering based ICs for measuring the energy, calculating the energy. So these things normally available in the basic thing. In the medium thing, we can have extra parts, that is the display and battery switchover, anti-tampering. These things available in the medium level hardware architecture. In the advanced level, we have RF based communication, Ethernet based communication, GSM, then smart card reader, IR remote things. So these things available in the advanced metering reading technology. So it has 3 different classifications, starts from basics to advanced. So these are the various benefits of AMI technology. So it will be used for various stakeholders. It starts from utility customers to marketing and load forecasting. So with respect to utility customers, so you can read many benefits. So better access and data to manage energy use, more accurate and timely billing, improved and increased rate option. So suppose we are using a time of use tariff. Based on the time of use tariff, we can switch over our appliances, power appliances from peak hours to off peak hours, so that we can reduce our electricity bill. Improved outage restoration, power quality data. So these things easily available when we use AMI technology with respect to utility customers. Then customer service and field operations, the various benefits available. So reduced cost of metering reading, reduced trips for off-cycle reads, reduced call center. So these are all with related to foreign countries. Then revenue cycle service, billing, accounting, revenue protection. So reduced back office rebilling. So these things are related to utility. Then with respect to transmission and distribution, so based on the data available in the AMI technology, we can easily improve transformer load management. So suppose a subsystem, substation has a transformer with a very high peak loads, then it can be easily managed. Then improved capacitor bank switching for maintaining our power factor. Data for improved efficiency, reliability of service, losses and loading, power quality data for the service areas. So with respect to industry, we should maintain our power with a very high quality. So these things are possible in the AMI technology. Then marketing and load forecasting. So reduced cost for collecting load research data. That means we can, in order to handle our load, uh, um, we are mainly focusing on renewable source, because renewable source are low cost energy. So if we know our load pattern earlier, so that we can easily get our renewable based energy at maximum level. So these are the various benefits of AMI. Then we touch on the communication infrastructures and protocols normally used in the smart metering. So wide area network, first one is neighbor area network, second one, final one is home area network. So home area network is an integrated system of smart meter, in-home display, micro generation, smart appliances, smart socket, HVAC facilities and plug-in hybrid electric vehicles. So all appliances normally connected in a house, which are monitored uh, through a meter. So these meters usually connected uh, among them through the gateway. So this part is called as home area network. So in-home display, micro generation, other meters, smart appliances, all are connected through home area network in a single smart meter. So every smart meter is normally connected together through some gateways or some RS485 protocol things, that is called neighborhood area network. So this is NAN denotes the neighborhood area network. So all neighborhood area normally connected through a data concentrator. This layer is called as wide area network. So this is the usual procedure used in the smart metering communication technology. So it is expected that HAN will provide benefits to the utilities through demand response and management program, management of micro generation, charging of electric vehicles. So these applications normally possible in the HAN area networks. So the main part in the smart metering technology, that is the connections AMI technology, is data concentrator. Usually it acts as a relay between the smart meters and gateway. It manages the meters automatically, detecting them, creates and optimizes repeating chains, coordinates the bidirectional delivery of data and monitor the condition of the meters. Usually, all smart meters data will be gathered through RS-485 protocol. So it comes up to data concentrator. So once all data are received in the data concentrator, after the data concentrator, that is from data concentrator to the server, usually we are using the LAN protocol for communication. So every data concentrators are having its own IP address. So using the IP address, we can easily fetch each concentrator through the LAN connection or wireless connection. Then meter data management system, this can be possible using PLC technology or GPRS based technologies. So these are the basic things usually available in this smart meter technology. Now we move on to the main focus on the state of art of our research available at TCE campus. Up to this, any questions or queries you can raise?
Participants, do you have any queries? Sir, you can move on, sir.
Okay. So in the year 2018, I have received one DST funded, SCRB funded project, demand side management. Using this project, we first installed around 20 smart meters in our college premises. So all smart meters are connected through the LAN connection, and all meter data are managed through L measure software. So now we have around 60 plus smart meters in our campus. We are gathering 24/7 time smart meter data, around 20 plus data we are gathering in our server with the timestamp of 5 minutes, each 5 minutes. So it affiliated at the main feeder, department-wise sub-feeders and end laboratory utilities. It connected mainly to the centralized server system through a concentrator. So these are the blocks we are having in our college. So in every block, uh, there is one feeder from powerhouse metering. So in each feeder, we fixed one smart meters. So each smart meter will usually measure all the data. So from starting from voltage to power factor, some low accuracy power quality based things can be measured using this smart meters. So all smart meters, as already discussed, are connected through a gateway. So up to this RS-485 protocol is used. Once it comes to gateway, the LAN port is normally used. It may be a wired or wireless port. So through this LAN port, all data is gathered in a server available in this laboratory. So once we receive the data, we can easily analyze what is the pattern and what are the things we can move ahead. So some analysis research work we already carried out using this data that I will discuss later. Then we installed some meters to analyze our intra-departmental infrastructures. So especially in our electrical department, we installed around 5 meters for measuring the consumption of each laboratory. So applied electronics, electrical machines, measurement, computer lab, and simulation lab. So why we are installing these meter means using the data gathered through these meters. Once we analyzed the data, the laboratory hours and the timetable can be easily switch over. Suppose if our entire college building power reaches the peak demand, then we have to pay the penalty. So in order to avoid this penalty, we can easily switch over our laboratory hours from peak hours to non-peak hours. So these things we already done and executed. So some papers already published. So then some departments are having far away from this server system. So for that thing, we are using a GPRS based communication protocols. So mainly architecture department and girls hostels, they are having these facilities. Then in order to manage or in order to analyze import export thing, so we are having one smart meter with the facility of net metering. So that means power import and power export. These things can be easily using this net metering technology. As already said, this is one type of smart meter. So we have around 480 kilowatt net meter installed capacity of solar PV panel. So this is the facility which usually we are having in our college campus. Now this facility can be presented like a layer wise things. So usually all sensing elements or all things are available in the physical layer. So that is our college infrastructure. Then in the sensing layer, all meter data, meter sensing things are available. So that is in the second layer of our communication. Then the third layer is communication layer. So from the sensing layer to communication layer, suitable protocols normally used to collect the data. That is mainly MQTT broker, MQTT protocols usually used. Another thing is storage layer. So data gathered from all the meters are stored in a server system that is based on the database logger, MySQL server. So these things normally used in this data storage layer. Final thing is, once the stored data is visualized for analysis purpose, that layer is called visualization layer. Usually this procedure is we are following for writing a paper, research paper related to this smart grid. So this is the our LNet L measure metering system software we are using. So using this software, we can easily know which type of meters or what type of meters are available. So normally this red color indicates the meter is not in use. Green color indicates it measures the parameters, it has the load. That light blue color indicates there is no load in that meter, in that feeder. So these things can be easily known from this server system. So meter on, meters off, no load meters. Then these are the parameters we can easily measured from this one: power factor, THT, so voltage, current, and everything. And these are the various meter feeder where meters are installed. So meter retrieves about 266 electrical parameters. So it compares simultaneously with respect to meters, feeders, parameters as per user choice. So we can tick what are the things we need. Once we get all the things, all data will be stored, downloaded in an Excel file. So using the Excel data, we can easily analyze various things. So various energy records, so feeder wise, group wise, selected group wise, then single shift, then energy report with respect to 15 to 30 minutes, hourly, daily, monthly, TOD reports, day log, multi-parameter day log, multi-device day log, multi-device and multi-parameter day log. So various types of reports can be generated, downloaded, from the LNet software. Then if we have a good facility, we can do this control access, that is energy and process monitoring, demand control, power factor control, power analysis, THT analysis. So these things can be done with the help of IoT based devices. So as of now, we are not having IoT based control in a real time. So we have a prototype level control access in our campus. So this is the pilot studies with a EEE department's monitor data. So the first pilot study we did is pattern extraction. So based on the seasonal wise, based on the seasonal variation, we have taken the pattern extraction. It's from 4 different seasons we consider. So almost in all seasons, as we are having an educational institution, there is much difference or much variation among each season. This is the first basic thing, analysis in the pattern extraction. The second thing is clustering and prediction. Clustering and prediction. So this is an important thing when we go for data analytics. So this is the procedure in the pictorial representation. You can see the procedure wise clustering and prediction. So it starts from getting the data and cleaning the data. So sometimes the data will not be available due to the failure of power failure or some other communication failure. So these data should be cleaned, that is missing data, imputation, outlier reduction, then normalization, discretization, time stamping, implementation. So this is the first layer, that is data collection and pre-processing of layer. So our data also gone through this layer, and it moves to the next layer, data analytics and visualization layer. That is the first one is demand pattern. So whenever we go for any analysis, the first step is we do our pattern analysis. What is the behavior of our pattern, how it behaves, like that we have to do. So various generating patterns we have to do. Based on the pattern only, we can either go for prediction or classification or clustering. So in the clustering thing, we have a optimal K value. We can easily identify formation of clusters, how many clusters, either it go for 2 or 4. So these things, that is based on the various algorithms, we can do it. Then once we do it, the next one is generated data validation layer. So we have to validate, first train the data set, valid data set, test data set. Then evaluation layer. So based on the evaluation layer, we can come to some solution. So how we can move further, and what are the suggested possible solution can be given for our consumer. So these things can be taken from dataset evaluation layer. So this is one part of result we already taken from our EEE department. So here elbow curve, I think you might not know about this thing. So all 4 season wise, we have elbow at 2. That means number of clusters here only 2. So there are 2 clusters normally here available in the EEE data. So this is cluster 1, this is cluster 2. So here you can see. Then some analysis can be done using various types of machine learning algorithm, ARIMA model, LSTM model, and every time series control. So we can have some analysis related to this, so that it will be useful for our research paper write up. Now we move on to demand side integration. How we can have based on our data, how we can implement or how we can utilize our data for the benefit of people. So demand side integration is a set of measures to use loads and local generation to support network operation or management and improve the quality of power supply. It measures a set of measures to use loads and local generation to support network operation. So DSI can help defer investment in new infrastructure by reducing system peak demand. In practice, the potential of DSI depends on availability and timing of information provided to consumers, duration and timing of their demand response, performance of ICT infrastructure, metering, automation of end-use equipment, pricing contracts. So I explained clearly here. Demand side integration is nothing but a set of measures that will be taken by the utility for the benefit of the entire power system. So using these measures, people, that is a consumer, can also get benefited. So various technologies used in this DSI, that is, first one is demand side management. That means utility activities that influence customer use of electricity. That means a particular TNEB, a particular utility, they can provide some incentive scheme or some other benefit scheme for the influence of customer for their usage of electricity. That means the user or customer can trim or can increase their electricity based on the tariff. Suppose in peak hours, utility will give a high tariff so that consumer should not use or reduce their utility usage of electricity. So encompass the planning, implementation and monitoring of activities designed to encourage consumers to change their electricity usage pattern. Then second terminology is demand response, it mechanism to manage their demand in response to supply condition. So nowadays we are mainly depending on renewable based system. So they are all a nature dependent system. So our response or our consumption should follow the supply condition, that is called a demand response. Demand side participation, it's a set of strategies normally used in a competitive electricity market by end use customers to contribute to economic system security and environmental benefits. So these are the services can be done provided by DSI, demand side integration, load shifting, value filling, peak clipping, dynamic energy management, energy efficient improvement, strategic load growth. So these are the core area of smart grid. So these things can be possible only because of smart metering technology. The first one is load shifting. Consider this is a load curve of a particular company or particular consumer. Based on this load curve, you can have you can see two uh, peak hours. So from 6 to 8 as well as 18 to 22. So two different peak hours here, and the highest peak hour is 18 to 22. So peak demand are available from 18 to 22. The load shifting mechanism is shifting the load from peak hours to off peak hours. So here the shaded portion is shifted from peak hours to off peak hours. So when we see the energy consumption during this period is remains same from before load shifting and after load shifting. Only the portion of demand will be shifted from peak hours to off peak hours. The second part is valley filling. So here the off peak hours loads normally in during off peak hours the load will be reduced. So the peak hour load is high. So when we fill some valley, so we are introducing or include some extra load or the load which are operated during peak hours. Some power load can be easily shiftable load can be used in the valley filling thing. Peak clipping means here peak load is, some peak loads are cut off. So shutdown is possible here. Mostly this peak clipping is not possible in the real time because some consumers are affected during this peak clipping. Energy efficient improvement, some energy efficient appliances, we can have our load curve from this to this. So we can reduce our load curve consumption. So what are the strategies normally used for implementing the things we already discussed, that is valley filling, peak clipping, load shifting? That is based on the price-based schemes. So encourages customer load changes in response to changes in the electricity price. Incentive-based schemes also available, customers load modification incentive. So suppose when we use normally a washing machine at 8 o'clock, we are forced to use our washing machine at 6 o'clock, morning 6 o'clock. So that that washing machine is running under off-peak hours. So when we use this, if we get an incentive, we use the same procedure every day. That is called incentive-based scheme. So then another thing is time of use tariff. So in India, we are using not using the time of use tariff, not using the time of use tariff. Time of use tariff is nothing but use different unit prices for different time blocks. So TOU rates reflect the cost of generating and delivering power during different time periods. Then real-time pricing is also available, critical peak pricing. So for a critical, for a peak time, some prices are very high. So here you see, this is the time of use pricing. This is a real-time pricing. This is critical peak pricing. So during the critical time, the price will be very high. The cost of the electricity is very high. Then another incentive-based schemes, price-based schemes here we listed. So these are the hardware we need to implement this DSI implementation. Load control switches, controllable thermostat, lighting control, adjustable speed drives. Then we have a prototype model for the introduction of IoT-based demand side management. Here we consider a load related to shiftable loads and non-shiftable loads. So that means interruptible or uninterruptible load. So our main focus on the shiftable load. Shiftable load can be shifted from peak hours to off peak hours. So here you see, so we are writing some objectives for doing this one: minimizing electricity cost, improving user comfort, leveraging renewable energy. So the significance role of this IoT is optimizing energy usage in the institutional thing. So usually we have different types of sources, 3 different DG, solar panel, electricity, TNEB electricity. So these things will be managed effectively based on our IoT based devices. So mainly objectives we are using is minimizing the electricity cost, improving user comfortness, leveraging renewable energy. Categorize a wide range of loads for allocating suitable time of operation. So for these things, we need data collected from the smart meters. Then accountable reduction in peak to average ratio and peak demand. So these can be achieved using this IoT based DSM to shift and schedule the load optimally by considering all possible constraints. So demand side management is a concept. So it's a problem of optimization problem. So in an optimization problem, normally we have to frame an objective, 1 or 2 objectives, then constraints. So constraints, that is with respect to user comfort index, shiftable or non-shiftable load-based things. So these things, once we program, then it can be possible to do this IoT-based DSM. Here we have an algorithm, hybrid algorithm, BPSO GSA. So that means we are integrating or hybridizing PSO with GSA. So this is the physical components normally used for implementing demand side management, smart demand side management system. So mainly a microcontroller, PZM module ESP8266. So this is the diagram, connection diagram for this demand side management thing. It what are the functions normally used in this is it monitors and optimize energy use. It utilizes solar power for peak periods. So I already discussed, we use this hybrid algorithm. So combination, it combines exploration of GSA and exploitation of binary particle swarm optimization. So usually in this demand side management, our aim is to switch on or switch off the devices, particular devices. So the parameters used inside the algorithm is only binary thing, either 0 or 1. So we use a binary based particle swarm optimization. This is the flowchart we are using, implementing in this thing. So day ahead scheduling and optimization normally used in this one. The key metrics we received, we obtained from our optimization technique is electricity cost reduction up to 35.27%. So when we implement this thing, we can reduce our electricity cost up to 35%. Then peak demand reduction is also possible. So up to 19%. Peak average ratio can be possible, reduction of 20%. So these things can be done in our optimization techniques. Then this is the real-time implementation picture. So everything is available, IoT enabled, SDSMS with solar integration. So mainly for monitoring or getting the data in visualization, we are using the Grafana software as well as Blink application. So this is the analysis graph we are using. This is the Blink notification we can have. So based on the outcomes, a hybrid algorithm is used for DSM and integrated into hardware for real-time application. Day ahead load shifting and scheduling is deployed. Performance of hybrid algorithm, that is cost reduction, peak to average ratio without DSM, with DSM, with the different algorithms here I mentioned. So these are the outcomes of our IoT based smart grid implementation thing. So peak demand reduction is also possible. So incorporating solar PV generation with this algorithm improves the system was implemented in the renewable energy laboratory for real-time monitoring using Blink application. So we come to the end of my presentation. So the summary of today's lecture is, we are first discussing the traditional to smart metering technology, highlighting AMI, advanced metering infrastructure technology, and then various types of meters available. Then pilot project at SPC campus with respect to smart meters as well as IoT based demand side integration we discussed. These are the possible areas to work further. Energy storage solution based things, predictive maintenance, that is one main thing, anomaly detection, optimize energy consumption and comfort, real-time automated control for dynamic energy management, demand response. Then communication-based research can be possible, cyber security, peer-to-peer energy trading, so vehicle to building, V2B, V2G. So these concepts, using this concept, we can go further for our research. Incentives and regulations through energy policy, data analytics, and digital twins, two-way communication technologies. So these are the various areas to work further. So these are my presentation. Now we are having some hands-on thing about Grafana software. My scholar, Ms. Parameshwari, I think he joined. She will explain
sir.
how to. Yes. She will explain how to integrate that use Grafana software when we use IoT-based devices. Ma'am, you can start.
Okay, sir.
After the session, I have one small quiz based on my presentation. So everyone participate in that quiz. You can share your screen first.
Sir, I couldn't share. Only meeting organization and the presenter can share.
Ma'am,
Uh,
just a minute, ma'am. Ma'am, I will share it. I will. Now you can check, ma'am. Ma'am, your voice is not audible.
Okay, sir. Sir,
Oh, yes, ma'am.
sir, is it visible?
Yeah, it's visible, ma'am.
Yes.
Okay, sir. Before going to do Grafana dashboard hands-on, I will give some idea about IoT-based intelligent source allocation system. From this, we know the importance of a Grafana dashboard. So the IoT-based intelligent source allocation system is to it's a compact device. Main aim of this device is to give the continuous supply to the critical loads in the commercial building. Here we have 4 resources of grids, solar, battery, and DG. From this, the supply from the sources are fed into the IoT-based intelligent source allocation systems. The IoT-based intelligent source allocation system consists of PSM module, Wi-Fi module, Raspberry Pi, relay, and multi-level voltage converter. PSM sensor is connected to the line from the supply. Wi-Fi module is to collect the real-time voltage and current. The Raspberry Pi processor receives the time series data from the system through Wi-Fi modules, which decides the priority of availability of resources. Then the information is sent to the cloud through Wi-Fi modules, which connects the consumers consumer's dashboard using the MQTT protocol. MQTT means message queuing telemetry transport protocol. This is the subsection of IoT ISAs. The supply from the sources are fed into the sources in terms of powers or fed into the microcontroller unit. Then the microcontroller, and at the same time, the decision tree machine learning algorithm is fed into the microcontroller unit. The microcontroller unit is to decide the available resources in terms of stability. Then it is fed into the that relay is to close the switch to fed into the sources are fed into the particular corresponding sources are fed into the multi-level voltage converter. That multi-level voltage converter is to convert the different kinds of voltages like 19.5 volt, 5 volt, and 24 volt. Then it is fed into the corresponding critical loads or power loads or primary loads in this section. The Grafana, before going to see the Grafana dashboard, we have to install the SAP control panel. ZAMP control panel V3.3.0. Here, the database are maintained in MySQL. This data are pushed into the Grafana dashboard. How can we connect the MySQL into dashboard? This is the SAMP control panel. Here, we have to start. We have to click the start. Then the PHP MySQL pages is presented. Then here in the Raspberry Pi unit, we have a query of, we have to give the query of MySQL. That only the data are fed into the MySQL database, MySQL server. Then I have to give some database like Solar alone. Here we have a 24 hours data, 1 day data. That data is from smart meter through Raspberry Pi. This 24 hours data is pushed into the MySQL, pushed into the Grafana dashboard. How can we connect the Grafana dashboard? Then open the browser. Localhost. Here I will give localhost 3000. Hi. Then the Grafana dashboard is displayed. Here, first we go for configuration section. Configuration section. In this configuration, first we go for configuration section. The configuration section, there are data sources, users, teams, then plugins, API keys are available here. First, we go for a configuration. In this configuration section, we go for first only data sources, because we have to push the data source into the MySQL, from MySQL to Grafana dashboard. This is the MySQL data that is pushed into the localhost 3000 or 3306, whatever you fed. This is the database name is SP in MySQL. The user is root. Then reset to the password section. Save and test. The database connection is okay and the data source is updated. Updated is displayed. Then we go for create the new dashboard. Here, the add panel is showed. Here we have to create the new panel. I am going to give solar alone sources. This is the new dashboard section. The Grafana dashboard only access the timestamp data, that is real-time monitoring data like current and voltage for 24 hours or yearly data are accessed. Here the data source is MySQL. I already gave that. Then from is solar alone only I have to give. Here in timestamp, time column, there is a timestamp. I will give solar alone. I have a resources of 4 resources, that is grid, then add column, then put grid solar, then add another source, another column, then add another source like DG, then add another column to put battery, then add another column to put primary load, then add another column to put power load, then add another column to put critical load. After that, after entering this loads and resources, then we go for timing, time field. That is last year or last 2 years. Okay. This is last 2 years data. The timestamp is, we go to see the timestamp of this. Which date we have to create that? We have to solar alone. Seven 8/2023. Put the date 7/8/2023. Click the seventh date that is shown in the absolute time range. Apply time range. So there is no field is created because data is not correct. The data field is missing. Then we go for another, discard this. Then we go for another example of this. Reset. Save and test connection. Then create the, add a new field. Here we have to see the solar tracking and solar no tracking. Add a column and solar track. If you don't want means here we can click remove that field. Then we go for last 2 days not coming. Last 30 days. Good. Last 7 days. Then go for solar TRF. $611. Last 90 days. Fill that time range. 611. Apply time range. There is some problem. Please wait for some time. Okay. Apply time range. Aggregate function gives aggregate average. We'll show the result. Then we please wait. MySQL SP reset, then go for save and test connection. Then we have to create the new dashboard, that is add new panel. This is the all source grid, add column, solar, add column, battery, then add column, DG, then add column, primary load, then critical load, then I put power load, grid, solar, battery, DG, primary, critical, and power load. I will give last 5 years, then put time range of that field. Sorry, I'm not able to give data source connection. Okay, all source. Okay, then I will give this field. I have to open this all source available. Then I will give new dashboard to create the all sources 7, 8, 20, 20, 23. Sorry, the data is missing in a number field, so that I can't able to show. Please give some time. Put the exact date to create the dashboard. Sorry, 5/11. June, July, August, September, October, November 5. Then put aggregate function to average. The data sources on the 5/11. Then what problem? Put 30 days. Put 30 days and days. 5/11. Okay. This is the solar tracking and solar no tracking results. Here, without solar, what we have uptime. Then with the solar, without solar tracking, what we have uptime. What is the difference between the solar tracking and the solar no tracking? This result is, here we have to give the title. The title is solar tracking and no tracking. That is shown in the panel title. Okay. Then we have to line interpolation. The line interpolation is like this, means that will show. Then the line with this, then increased. That is intensity. That is intensity is increased. Line with this increased. Okay. The line with this increase the intensity of this. Okay. Then fill opacity. That means fill color of this circuit. Here we have to select the color like orange or yellow or blue or purple, whatever we like that, we have to fill this. I want a blue color means that will change the color. Okay. This field is color changing field. Then we have to save this board. Solar track and no track. Save and apply this field. Then you have to track the full view of this solar tracking and solar no tracking results. This is the solar alone results. Then we have to snip this to project that paper. Then we have to open the Word to shown in the project the paper field. This is the way to make the visualization. Then if you have any 24 hours data with the timestamp, how can we put 24 hours data? We have to give how can we create the 24 hours data? That first we go for insert to. First we have to browse structure to create the table. Structure to create the table like this. First we go for new section. Table name, database name is SP, and the table name is solar. Then the column is solar only, times up with the solar tracking. Result only I have to create data. Solar, add columns.
Parameshwari,
Time and solar.
you can complete time 7:35. You can complete.
Okay, sir. Okay, sir.
Yeah. Anything you want to share?
No, sir.
இல்ல முடிச்சிட்டீங்களா இன்னும் கொஞ்சம்
Okay, sir. How to create that 24 hours data? database is created. The database name is Soul. Then save. Missing value in the timestamp. Soul. This is the timestamp field. Timestamp. First, you have to create the table name Soul. Add call. Here the database name is create the table and the timestamp is added. Date and time field is worked. And the soul is in float. Solar data values in float condition. Then put primary. In null index, we have to put a primary. Then we have to edit that. Save that field. Then we go to insert the field. The timestamp is first our data 01. So 0. And the soul value and the data is maximum midnight 1 p.m. value. Then go for next data. For that, following that, 24 hours data is this. Then we have to push the 24 hours data into the localhost Grafana dashboard. The data connection is then go for a data configuration section, and in that data configuration section there are database API keys. Most of them either following these are available, but we have to select a database section. Then we go for the databases collected in the MySQL. Then we have to select the MySQL. Then MySQL data is the database name is SP. So that we have to give the connection between MySQL and Grafana dashboard. Then we have to create the add new panel. In add new panel, we have to give the parameters. Like what are the parameters we have to take? Grid, solar, battery, DG, and critical load, power load, and primary loads. These loads are fed. These loads are put into the column field. Then we have to give the time range field. Here we have to give the correct time range of this section. Then we have to we obtain the results. That results then we have to give the panel title name. Then we have to adjust the panel size of the line width and colors. Then we have to save and apply that data. That field is shown in the dashboard. This is the way to make the Grafana dashboard. Thank you so much for thank you for your patience.
Thank you, ma'am, for briefing the about the visualization of IoT devices using Grafana dashboard. Hello. Ma'am, is there any other dashboard like similar to Grafana?
Ma'am?
Is there any dashboard similar to Grafana?
Ma'am, no dashboard is like Grafana dashboard, ma'am. If we use the ThinkSpeak, we can see the visual. We can visualize the board. But that problem is very because that is integrated into the MATLAB, ma'am.
So
No one
Grafana
is
is only for only for visualization we can use this.
Visualization software for real-time monitoring.
For real-time monitoring. Okay.
Yes,
Thank you so much, ma'am.
It's
Thank you
it
so
only
much.
access the time series data only, ma'am.
Okay, ma'am. Okay.
Without time series,
Participants, do you have?
we have to we don't, ma'am. Ma'am,
You can continue, ma'am.
without time series, we do not make the Grafana dashboard, ma'am.
Okay. Okay.
Okay, thank you, ma'am.
Thank you, ma'am. Participants, do you have any queries regarding the IoT implementation? If there is no query, then we will close the session. I like express my sincere thanks to Dr. Charles Raja and Madam Parameshwari for giving us this wonderful for giving us an insight on IoT implementation and like usage of Grafana dashboard also. Thank you so much, sir. It was very knowledgeable. Like it was very knowledgeable for us. How you have implemented in TCE campus that has given a lot of insight to us also. Thank you so much, sir. Madam, thank
Thank you,
you
ma'am.
for explaining about the dashboard also. Like due to lack of time, we have to wind up the session. Thank you so much, sir. Thank you so much, sir. Participants, you can take a break for 5 minutes and rejoin for the next session at 7:45. At 7:45, you can rejoin for the next session.
அப்ளிகேஷன் இல்ல அந்த கேஸ்ல அப்ளிகேஷன் 7600 ரூபாய் வீட்டுக்காரர்